Today we will be doing the third review lesson, and that is solving linear equations. So first of all, let's talk about an equation compared to an expression. An equation, if you look at that word, the first four letters are part of another word. EQUA are also found in the word equal. So an equation is something that has an equal sign. It's going to have one side that is equal to or balanced with another side. An expression does not have an equal sign. An expression is kind of like one side of the equation. So you would have this expression over here equal to this expression over here. Equation and expression are two separate things. So the first vocabulary word that we're going to cover today is solution. A solution is a value that satisfies an equation. In other words, a solution is a number that makes an equation true. And our N almost made it. Okay, so the value that satisfies an equation, or like I said, it's something that makes the equation true. So we could also say makes it true. Our next word is inverse operation. And we know that the operations of math are multiply, divide, add, subtract. Inverse means opposite. So when I talk about inverse operations, I'm talking about the opposite operation. So when we look at addition, for example, addition has an opposite. What's the opposite of adding? If you haven't thought of it, it is subtracting. So addition and subtraction are opposites of each other. And then multiplication, what's the opposite of multiplying? The opposite is dividing. Inverse operations are huge when we are solving linear equations. Everything about solving linear equations is opposite. So before we actually get into solving equations, I want to first go back to this first vocabulary word, solution, and let's mess around with finding solutions and checking solutions. All right, the question I am beginning with is x equals 2 a solution to x plus 8? In order to figure out if that's a solution, I have to take this 2, x equals 2, and I need to substitute it into x in my equation. So for substitution, always start out with parentheses. Instead of placing this x down, I'm doing parentheses with a 2 in place of the x. Next we have plus 8 equals 10. So I took that equation from above. Instead of putting an x, I put a 2. Now let's follow order of operations. And I know first thing in order of operations is parentheses. Well, there's nothing I can actually do inside my parentheses, so we move on to exponents, multiply, divide, add, subtract, and adding, is the only thing I can do here. So 2 plus 8 is 10, 10 equals 10. Is that true? Yes, it is. So I'm going to write yes. X equals 2 is a solution. Let's do one more of those examples. This time the question is y equals 5 a solution to the equation 2y plus 4 equals 24. So once again, let's start off by taking that 5 and replace it into that 5. So we have 2 times, instead of y, I'm going to do parentheses with a 5 on the inside. 2 times 5 plus 4 equals 24. Well, over here on the left side of the equation, we've got to simplify that. Order of operations tells me I need to do 2 times 5 first, and that's 10 plus 4 equals 24. And 10 plus 4 gives me 14. Does 14 equal 24? No, it does not. So my answer is no. Y equals 5 is not a solution. So taking x equals 2 and y equals 5 and substituting it back into our equations is a useful thing to know, because now when we go on to solving linear equations, you cannot get them wrong. As long as you take your solution and you plug it back into the original equation, you can always check and see if that solution really is the answer. If it doesn't work, then that tells you it's not the answer and it's time for you to go back and try the problem again. So an important thing for you to remember when you are doing these linear equations, I'm going to put a little star thing next to it, is that an equation is like a balance scale. So here's my horrible drawing of a balance scale. Remember, in a balance scale, if you put something here, then this side's going to drop down and this side's going to go up. We want to keep it centered and balanced right here. So think of your equation as if this pivot point is where your equals sign is. Oops. Oh boy, I'm having a hard time here. So the pivot point is like the equal sign. So if I add 2 to the left side of my scale, or my equation, I've got to add 2 to the right side as well. If I subtract 7 from the left, I have to subtract 7 from the right. You can also think of the golden rule, which is do unto others as you would have them do unto you. We can apply that to math. Do unto one side of the equation what you would do to the other side of the equation. So if we do something to the left, we've got to do it to the right as well. Let's take that principle and inverse operations and apply it to our first example. So our example is y plus 13 equals 0. First, I want to find my variable. My variable is right here, that y. Now I ask myself, what operation keeps these two together? The operation that's keeping them together is addition. So now I ask myself, what's the opposite of addition? Well, I know the opposite is subtraction, so I'm going to go ahead and do my inverse operation and subtract 13 from here. Remember, this equal sign is like the pivot point of our scale, so if I subtract 13 from the left, I have to subtract 13 from the right. 13 minus 13 is 0, that's gone. 0 minus 13 is going to give me negative 13. So all I have left is y, I have my equal sign, and I have negative 13. Let's go ahead and check that. So I'm going to take my solution and substitute it back into the original expression. We'll do a different color. So instead of y, I have negative 13 plus 13 equals 0. Well, what is negative 13 plus 13? That's 0. Since that is true, it tells me that yes, y equals negative 13 is correct. Let's do 3 more quick examples. On all of these examples, we are going to be doing just one step. So first we have b minus 9 equals 19. So I ask myself, what is the variable b? Next I ask myself, what operation is keeping b with 9? Subtraction. Finally, I ask myself, what is the inverse operation, or what is the opposite of subtraction? And that is addition. So let's get rid of that 9. I'm going to add it to the left side of my scale. I also have to add it to the right side of my scale. And 9 minus 9 is nothing. Those are gone. So the only thing left is b. 19 plus 9 will give me 28. Finally, I'm just going to go ahead and check my answer. So my solution, 28, is going to get substituted back into this original equation. 28 minus 9 equals 19. And let's simplify that. 28 minus 9 is 19. 19 equals 19. That is true. So we have a correct answer. Next, we'll check out a multiplication example. Negative 9g equals 36. What is my variable? G. What is keeping negative 9 next to g? That is multiplication. Anytime you see two things side by side, that means you are multiplying. So if multiplication is keeping them together, then what is going to break them apart? That is division. So I'll divide the left side by 9, divide the right side by 9. Remember, I'm trying to get rid of that 9. So when I divide by 9, it cancels out. It's gone. The only thing left is g. 36 divided by 9 is going to give me negative 4. And let's check my answer. Negative 9 times negative 4 equals 36. I know a negative times a negative is a positive. 9 times 4 is 36. Since that is true, that means my equation is true. G does equal negative 4. And our final example of this one step is b divided by 4 equals 7. So, first question. What is my variable? B. Second, what is my operation? Right here I have division. And third and final question, what is the inverse operation, or what is the opposite of division? And the opposite is multiplication. So I'm going to go ahead and I'm going to multiply both sides of this balance. And the number that I'm going to multiply them by is the number that I'm trying to break away from b. This 4 is what I'm trying to get rid of, so b can be alone. So let's multiply the left side by 4, the right side by 4. 4 over 4 cancels out. So on the left side, I notice the b is the only thing I have left. I have my equal sign, and 7 times 4 gives me 28. Go ahead and pause the video, and I want you to take b equals 28, and I want you to substitute it back into 4, or into b over 4, and see if that gives you a correct solution. Okay, well, let's check it out. So I substitute 28 in place of b. It's 28 over 4. And we have equals 7. 28 over 4, or 28 divided by 4 is 7. And that is true, 7 equals 7. So I must be correct. Okay, I threw those 3 questions that I've been asking myself at the top of this slide. And we're going to keep referring back to those questions, but now we're going to move on to 2-step equations. Previously, we were just doing 1 step. You just multiply, or you just divide, you just add, you just subtract, and then you find your solution. Now we're going to have to do a couple things. So the first example is negative 9x minus 13 equals 23. Now, we just spent the last few days working on order of operations, and I kept telling you, save addition and subtraction for the end. Save it for the end. Don't add and subtract until there's anything else to do. Nothing else left to do. Now I'm going to say the opposite. When we are solving equations, we're kind of going backwards. So we're going to go backwards through the order of operations. The last thing in order of operations, you'll remember, is addition and subtraction. So rather than waiting until the very end to do addition and subtraction, I'm going to start this with addition and subtraction. So I notice right here, I have my variable, and I have multiplication that's keeping it with the 9. I also have subtraction that's keeping it right here with the 13. Since I'm going opposite the order of operations, I'm going to start here with this negative 13, or the minus 13, and get rid of it. So I ask myself, what is the opposite? The opposite is addition. I add 13 to the left. I add 13 to the right. Negative 13 plus 13 is nothing. It's 0. Now I have negative 9x, the equal sign, and then 23 plus 13 is 36. Now I have to do my second step. I need to break up the negative 9 and the x. So, to do that, I ask myself, what is keeping the negative 9 next to the x? Multiplication. What is the opposite of multiplying? Dividing. So we're going to divide the left side by negative 9, so we can get rid of that 9. Divide the right side by negative 9. And what I'm left with in the end is x. I'm left with my equal sign, and I'm left with the number negative 4. Let's go ahead and take a look at just one more of these. This one will be a little bit different. 13 plus y over 4 equals 10. So, what is my variable? Y. What operation keeps it with everything else? We have division and we have addition. What is the inverse? Well, I want to start with addition or subtraction. So I'm going to look at this positive 13 and say that the inverse, or the opposite of positive 13, is negative 13. So let's subtract 13 from the left, subtract it from the right, and on the left side I'm left over with y divided by 4, and on the right side I'm left over with a negative 3. Now, what is the opposite of division? Multiplication. So let's multiply both sides by 4. And my 4's, they are gone. I am left over with y equals negative 3 times 4 is negative 12. And of course we can check that solution as well. We can also check y equals 4 by substituting it back in to the beginning. So, the main points to remember: whatever you do to the left side, you have to do to the right side. We always use inverse operations, and then also that we always go opposite the order of operations. So we start with addition and subtraction, then we do multiplication, division. Once all of that's gone, then we can take care of exponents, and then we can get rid of parentheses. So really everything, if order of operation goes this direction, when we're solving equations, everything goes this direction, goes the opposite. Don't forget to take your quiz at the end of this, and rewind, retake notes, watch anything that you need to watch again, and be ready to work on an assignment with this tomorrow.